Hey there, Science 10s. Today, I would like for us to make a little study card. And on this study card, we are going to summarize the different types of ionic compounds that we would see. So, essentially, we know for every ionic compound, there's going to be a metal. So you can take a piece of paper, a white piece of paper, put a box around it like I have done here, and you can just copy these notes down as I'm walking you through this, okay? And I'm going to post a little key of this as well. And this is every time you get an ionic compound, you're going to follow kind of these steps. This is your thinking process of how do I figure out the name or the formula of this ionic compound. So the first you ask yourself, is there a metal? Well, if there is, then obviously it is an ionic compound. Now, again, where do we find the metals? So looking at your periodic table, remember this staircase here? Everything to the left of that is where the metals are. All right, so there's a whole bunch of metals, and you become familiar probably by now with a lot of them. So once you've identified that, yes, there is a metal in this compound, now you know that it is going to be an ionic compound. So let's carry on now with our little naming card. So you're looking the metal up on your periodic table. You're looking on the left side of that staircase, as we just saw. And we are going to ask ourselves, does the metal have only one charge, or does it have more than one charge listed in the top right corner? So here's some examples of a univalent. If there's only one charge listed, so if you're looking at group 1, you would find guys like lithium and sodium and potassium, all down that very far left side, group 1. They only have one charge listed. Why? Because they have lost one electron. They can only make an ion with one charge. They're univalent. To the group beside them, group 2, beryllium, magnesium, and this guy, calcium. Look at his charge, 2 positive. That's only one charge. There's not two charges listed there, a 2 positive and a 3 positive, or a 2 and a 1. That's only one charge. This guy is univalent. Likewise, if you go over to group 13, kind of almost beside the staircase, we see this guy, aluminum, and again, one ion charge. He is univalent. So how would I write his name? If I was given a compound and I knew there was an Al ion in it, and I just write it aluminum. If it's calcium, just calcium. You just keep the name the same as it is on the periodic table. But wait a minute, what if there's not one charge? What if this is one of the guys in the middle of the periodic table? And again, the guys that I am talking about kind of in the middle here, right? These are the ones, the transition metals. Many of them have more than one ion charge. Well, those guys are the multivalent ions. And so, for instance, copper. How do I know which copper ion we're referring to? Well, there will be a number in brackets. So copper 2 chloride, that is telling you to choose the 2+ ion. So you have Cu 2+ ion. What about the chloride ion? Well, remember, chloride is a non-metal, and we look him up on the periodic table and we see Cl. Well, it does not tell us what the charge is, so we have to figure that out by looking under what group the chlorine is in. So here is chlorine. We know that he is a non-metal. Why? Because he is on the right side of the periodic table. I look up to his group. The last digit tells me that he has 7 electrons. This last digit, 7, he has 7 electrons. So remember, the magic number is 8. That means he has to gain 1 electron to make a full octet, to have 8 electrons. So what is his charge? 1 negative. Everybody in group 17 is a 1 negative ion charge. Everyone in group 16, 2 negative, all the way down. Nitrogen, nitride, phosphide, arsenide, those guys are all 3 minus. Because again, they're gaining electrons. Okay, so that being said, let's go back and finish off the name of this compound. All right, so we've got Cu is 2 positive. Chloride is 1 negative. Sorry, we've been given the name. Now we have to put these together to make a formula. So we've been told to use the 2 positive charge. That's what this number in brackets means. So I've got a 2 positive, but a 1 negative. Well, that charge does not balance to 0. So I have to times this by 2. So my formula is going to be Cu Cl2, and make sure you add that state. This is an ionic compound. We write solid for the state. Okay, what about this next guy? Gold 1 nitride. So which gold ion is that? Well, this is the multivalent, and they're telling you to use Au1+. Nitride, we just did that guy. He is a group 15, so he has an N3 minus charge. So put those two things together, make a 0 compound, 0 neutral charge is what I'm trying to say. I've got to times this guy by 3. So the formula for this, Au3N, and of course it is a solid. Don't forget that state. All ionic compounds are solids. Okay, so there we have how to tell apart uni and multivalence, and we've spent a fair bit of time doing that. Now, there's one other type of ion, and so we are going to look at that last type of ion, and that is looking at the ending of that second word. If that second word ends in "ite" or 8, then where do we look? Well, we look up on that polyatomic chart. The polyatomic chart, the polyatomic table. So when we look up in the middle of our periodic table and we see this table of common polyatomic ions, we know that there is polyatomic, more than one atom in each of these ions. So here, our very first example, CH3COO minus. 1, 2 C's in that, 3 hydrogens, 2 oxygens, and the total charge, they're all sharing a negative charge. All right, so that guy's name, acetate. So again, if you find an ATE ending or an ITE ending, that automatically means you go up here and you look at this polyatomic table. Okay, now this guy, you see him as acetate. He has another name, ethanoate. Okay, so you see some ITE ions, nitrite, nitrate, iodate. Okay, so a lot of them have those ITE or ATE endings. There are a few exceptions, right? There's a couple of very common ones that you're going to use a lot. Hydroxide, it's not an ATE, it's not an ITE, but it is polyatomic. Why? Because there's 2 different atoms. There's an oxygen atom and a hydrogen atom, and they share together a negative charge. So that makes them an ion. Okay, so remember, the polyatomics are the ones that have more than one atom. And these are not the guys who are just like group 16 or 17 or 18 ions. Those are your IDE endings, nitride, phosphide, iodide, bromide, etc. Okay, so here, guys, you can make this up into a little study card. Put this on a piece of paper and have it handy for when you are doing your practice questions. And every time you see a metal, you make that decision. Is it univalent, 1 charge, multivalent, more than 1 charge? And what number do I put in brackets? Well, that number will be the charge that I'm using. Or is it one of these polyatomic ions that has their own special chart and they have their own special names? Okay, that's it. That's all for now. Until next week, if you need any help, you can contact me, michelle.ledeen@ghsd75.ca. Talk to you later. Take care.